Hey, there we go. Welcome in, friends. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Fritz, and today's another C# with CSharpFritz episode. We're going to be talking about all kinds of cool C# stuff today. We're going to get in. I want to do a little bit of advanced content discussion. I want to talk about and show you how to build a Roslyn analyzer, how you can build some code that will help you maintain and edit code. A whole lot that we're going to get into today. I'm taking a quick look. I see there's an issue. Yeah, look at that. The description is just off. There, that should fix over there on YouTube. Welcome in. We've got folks we're broadcasting to Twitch, and we're broadcasting to YouTube today. So good to see you. Looking over here at the chat. Let me say hello to the chat room. They're right over there. Hello, I see Ed Key is here on YouTube. Nitro Evil, good afternoon to you. Good afternoon, Shy Sharp. Ancient Coder, happy Monday to you. Yeah, I cleaned up the GitHub link. There you go. Arun, we'll get to your question in just a second here. Let me finish welcoming folks in. Charles Galuli, good morning to you. Mohammed, hello. David, hi, how's it going? If you're testing Android, you want into... I'm not going into that today. AJ. All right. How's it going, Robertson? So we're gonna cover. I want to do a little bit of advanced C# today. I want to start off with a brain teaser to kind of get things going. Of course, AMA is on. Ask me anything, any topic around .NET, Visual Studio, C# programming. I'm happy to answer, and I want to leave some time up front here so we can catch up and make sure that folks are productive, that you get some answers to some of your common questions. And, well, not even if they're common questions, just so we can get in and make sure that you're ready to go, that you have some of the knowledge that you need in order to be productive. And we're going to we'll like I said, we'll get into a brain teaser all about how C# works. And then we're really going to dive deep. This is not going to be for the faint of heart. We're going to get in and build our first Roslyn analyzer. Now, this is a demo that we're going to be using that was posted to the blog some time ago. But it's a simple example that's going to show us a bunch of things about how to set up Visual Studio so you can build an analyzer. How you can get involved, get in and start pulling apart source code and understand how that source code it works together, how the compiler sees your source code, and then raise appropriate error messages for scenarios that are going to help make your code better. Let me say hello. I see a bunch more folks over here on YouTube. Hello. We're also on the Visual Studio Twitch channel. We're on .NET over on YouTube. Hoy is here. Ali is here. Roberson, John Steven Taruk, Zaiden C, Praveen, Hassan, Ahmad. Yeah, over on the Visual Studio channel. Mohit, DBC Codes. So nice to see C# community events like these. You're going to see these all the time. We want to continue lighting up and bringing some great content to you. On Twitch, on YouTube, and this isn't about me giving a lecture. This is about having a discussion. This is about learning together. There's samples available. You can go and download documentation. You can go and download samples out there. But this is about having those discussions that are so valuable that, you know what, when you're at home, maybe you're just having coffee first thing after breakfast like I am, and be able to get in and have that wake up, have that little bit of developer talk radio that we can enjoy together. Davi, hello to you in Brazil. Good to see you. Carlos is here from Cabo Verde. Nice. Chris Jones, hello. Good to see you. TN, is it okay to do C# on Linux? Oh, yeah. Yeah. It's very okay, TN, to do C# on Linux. Look, over on my other channel, CSharpFritz, on Twitch, we do a lot of C# on Linux. We do C# on Mac. We do it on Windows. But we do a bit of it on Linux. In fact, we're building and publishing applications that are deployed to Linux containers, to Linux app services. So folks can interact with them and, it doesn't, honestly, if you're building a web service, if you're building a website, you deploy it to a Linux service, it doesn't matter. It shouldn't matter to your end users. So, yeah, direct communication, absolutely. That I completely agree. That's Fireball Monkey over there on Twitch. Let me continue scrolling through the list here, saying hello to folks. But absolutely, you can do C# on Linux. And in fact, I'm setting up for a series over on my stream. I've been building and working with Azure Functions on my channel. Well, what if we built an array of Raspberry Pis? Now, a number of folks have done this. My colleague Scott Hanselman has done this. But what if we built an array of Raspberry Pis live on stream, deployed Kubernetes to them, of course, live on stream, learned all about that. That's all Linux. And then let's deploy .NET Core, .NET 5 based, or .NET 6 applications to that, and learn more about load balancing and managing our applications running on a cluster with a collection of Raspberry Pis. I think that's going to be a really interesting series for us to get into. Probably a week or two out in August. We'll see how that lines up. Can I famous C# topics for solving problems of unknown clients? Wow, I have zero context on that, Praveen. I don't know where to even start answering that question. I'm sorry. Benny83, looking forward to this stream. Oh yeah, cool. Thank you. Roman is here. Yeah, Roman says Roman is here. Okay. Veronica and Alexandru, hello to you in Moldova. Alex from Italy is here. Let me see here. Aleph from Brazil. Could I record Orleans lessons? I haven't really used Orleans, so I'd have to spend some time learning that. Ancient Coder, you got the channel spelled just slightly wrong. Let me talk to some folks and see what I can do about Orleans. Next week, we're going to have Shane Boyer joining us, and we're going to go over Open API, go a little bit deeper on that. We had a request come into the GitHub repository about talking further about Open API, so we'll learn a little bit about that. Jim is here from Calgary, Alberta, Canada, from the YYC airport code. Nice. Continue scrolling. You're doing C# with Vim on Kali Linux, says Oxgran27 over on, well, it's not Oxgran, it's 0xGrand, over on Twitch. Good morning to you, Vortex. Let's see, Ugo from Poland, Nua from Norway. My goodness, so many folks signing off here. This is great to see. Thank you so much. Greetings to you, Surly Dev in the UK, Lutfi in Indonesia. Jose is here from the Dominican Republic. How do you set up syntax validation? Yes, OmniSharp works fantastic on Windows, Mac, and Linux to give you syntax validation, particularly if you want to use a text editor that's not really known for syntax validation like Vim or Emacs. Works great there. Alan over on Twitch. Good hello to you in Brazil. Erdem in Turkey. There you go. Thank you, Surly Dev, for posting the correct link over there on Twitch. Super Viking has a question about deploying a .NET Core app via Azure App Service. Why wouldn't I choose Linux? Less expensive, right? Let me pause on that question because that's a really good question that we should touch on here. Let me. Nope, featured chat is not going to agree with me today. So when you're deploying .NET Core via App Service, you may want to choose Windows because Windows has tight integration with Active Directory, with Azure Active Directory. So you're going to get that instant validation that your application is who it says it is, so you can go and interact directly with not just with Active Directory, but with the secure vault. So you're interacting, you're getting data, you're getting secrets out of your Azure Key Vault without any without having to write any additional code or to go and authenticate. It's just there. Your application can directly be authenticated for it because you're using Windows. Analyze that. Yellow Cab Company is here. Okay. Let's move into this. Some folks fully vaccinated today, says Janescu over on Twitch. Nice. Praveen is a beginner in C#. Which channel do I prefer for learning easily? If you watch here on the .NET channel, check this playlist, the C# with CSharpFritz playlist. There are dozens of videos here that are going to get you started with C#. I've got a whole collection of Jupyter notebooks. I'll show you where those are over on GitHub that you can launch and run in your browser. So whether you're using a tablet like an iPad or a Google Chromebook, you're going to be able to open those up and work and learn C# without having to install anything funny on your machine. So you can definitely check that out, and I'll show you where that is in just a few minutes here. DBC Codes loves the new SignalR library, works without having to worry about transporter or language. Yes, we're working hard to improve SignalR, make it just one step to get up and running. So yeah, it looks like featured chat is not going to work for me today. Let me see here if I can get that running. There we go. Logged in over to my Visual Studio dashboard. There we go. Got it. Will there be any streams on developing C# applications with Vim, asks Tejas. I did a whole month on it over on my channel over on Twitch. I have to get the videos published, but I've done it in the past. When we get into October over on my Twitch channel, twitch.tv/CSharpFritz. That's where you'll find me in October doing a theme month that I lovingly call Ubuntober. All month of October, we're programming with .NET on Ubuntu Linux. I'll be using Visual Studio Code on Ubuntu. I'll be using Vim. It's a full month where we're showing, you know what, .NET works wherever you want to be. Whatever editor you want to use. If it makes you happy to use Vim, you want to use Emacs, you want to use Nano, you want to use Pico, you want to use brackets, you want to use Atom, doesn't matter. it works wherever you want to be. C# workbooks, yes, work in the browser, yes, indeed, absolutely, you can do that. And we'll show you that. I can in just a little bit. I have a well, I'm going to open the workbook in Visual Studio Code, but I'll show you how you can run it in the browser as well. What are we going to do? Well, I'm going to finish answering a couple more questions here, and we're going to take a look at the GitHub repository for the channel for this series. I've got a brain teaser to ask you and discuss about how C# and how .NET works. Some interesting stuff there. We're then going to get in and start building a Roslyn analyzer. It says it in the title. If you look at the title, it's like right here. We're going to build an analyzer today. So let me see here. Arun asks, is there any difference in .NET programming on AMD Ryzen or Intel processor in terms of performance and compatibility? Both work the same with .NET. Both will work the same with .NET. That's kind of one of the things with .NET. You see the same with Java. You write the same code, and it will compile, and it brings the appropriate runtime for the processor along for the ride. Now, when you're running on Windows, when you're running on Linux, you're typically going to install and get support for the 32-bit, 64-bit processor and all of the interactions with the various cores. And even though they're two different architectures, Ryzen and the Intel processors, it'll work with them the same way. You as a .NET programmer don't have to worry about that, quite like if you were a C++ developer. However, there are techniques, there are ways that you can invoke and get down into the processor that may be a little bit different, not so much between the Ryzen and Intel processors, but certainly when you get in and you start working with x64 processor, ARM64 processors, then you're going to start to see a little bit of a difference between the runtime and some of the features that are available to you, just because it's a different processor architecture from working with the Intel or AMD typical processors. Let me get some music playing in here in the background, and I'll come to some more of the questions that are there in the chat room. I'm going to play the Stream Beats playlist. Of course, I'm going to load up. Let's do the lo-fi playlist today. This is groovy music that's available for you to listen to. Instrumental, very chill, very relaxing. Just take a deep breath, write some code together. This is made available from streambeats.com. There's playlists there for Apple, for Android, for Spotify. Check it out. You can even download the music if you'd like. Thanks so much to Harris Heller for making this music available for us to listen to, royalty-free, DMCA-free, wherever it is that you want to listen to music. Thank you so much, Harris. Appreciate that very much. All right, let me take a look here. I see a handful more questions coming in. Will we ever get to a point where we don't need Visual Studio and just use Visual Studio Code for development? Asks James Foreman. You can do that right now. However, if you want designers, if you want analyzers, you want to build extra things into the .NET tools, into how you build and work with code, you're going to want to use Visual Studio 2019, Visual Studio 2022. So, continuing, looking here. Do you think they will make .NET able to make Linux apps soon? You can. You can. You can use, I mean, to make Linux console apps, sure. Make Linux services, absolutely. Make Linux GUI apps, that's something that the Microsoft team is looking for assistance from the open source community, and there are folks building frameworks that you can use to build Linux applications. It is not maintained by Microsoft, which kind of makes sense because these are the folks that manage and interact with the Linux community. They're the experts. Let them focus on that stuff. And yes, Linux is such a broad term, right? which distribution are you talking about? Which user interface stack? Then it gets kind of crazy. Then it gets a little bit tricky to manage and juggle all of those stacks. Let's see. You thought C# apps ran only on Windows? No. They run on Windows, Mac, Linux, IoT devices, in the cloud, all over the place. There's all kinds of games and apps that run on mobile devices. Absolutely. So, no to-do list. I don't use that over here on this channel. I don't. That's not a question for me. You can write Xamarin apps with Visual Studio Code, no, but you will be able to write .NET MAUI apps with Visual Studio Code. Coming soon. You want C# to make Java obsolete. All kinds of folks like all kinds of different languages, and that's okay. It's okay. You know, I don't want to. I want to discourage folks from saying this language, this framework, this tool is better than another tool. Everybody uses the tools that makes them happy, uses the frameworks, the programming languages that are important to them, that they want to be successful with. So, or that they already are successful with. That's okay. Go for it. Look, I prefer C#. That's the language that I like to use. My friend Don, he programs with F#. He's an F# developer. My other friend Guido, he likes Python. That's okay. Those folks are very productive with those tools, with those languages. And you know what? We can coexist. We can collaborate. That's all right. Yes, .NET MAUI is going to be a big thing coming up in November. So, you want Adobe to port their stuff to Linux? Well, I can't speak for Adobe. Why in Blazor WebAssembly can I modify an enumerable with select? Well, you're not modifying it. You're projecting it. When you use an enumerable, a collection, it doesn't matter if it's in Blazor WebAssembly or if it's in a console application or a WPF application like we saw last week. When you have a collection and you say .select, you're projecting, you're changing the shape of what you're returning to the calling method. enumerable.select says, give me content in this new shape, this new class, this new type that I want to interact with. Maybe you're just selecting out the name from a contacts table. That's okay. You're going to get just an array, just a collection of strings that are those names. And that might be what you want. You're not changing the array, you're projecting, you're getting a subset of it. That's what's going on there. Marcio over on Twitch. Hey, copperbeardy, good to see you. Can I give an example of about C# with... No. Check the rest of the playlist. There's dozens of hours, dare I say almost hundreds of hours of content, me explaining C# over there. And give an example? No, I can't. I just give a simple example. We're doing advanced topics today. All right. Yes. Hey, Jason. Love the topic. I'm only going to get into the basics of analyzers today. I want to whet people's appetite. So if you want to learn more, you can go dig into it further. And I'm noticing that my green screen curtain moved to the side there. Not a problem to ask the question. I've just got a ton of other content for that, and we wanted to get into an advanced topic today. All right. You're welcome, Marcio. And I hope that clears things up a little bit there with how that works. Let me see. Let's do this. Yeah, we've got time. All right. Wow. Whew, that was like That was like the turbo round, the speed round, the lightning round, going through answering questions there. Oh boy. All right, let's do this. I have. I'm gonna move that over here. Yeah, round 2. Polywraith says round 2, fight. Nah. Not quite. I do need to replace this with the restream chat, so we can see chat from both YouTube and Twitch over here. I'll do that before next week so that we have a full chat so we can see both chat rooms going on at the same time over here. All right. I think I'm about ready to go. Yeah, let's do this. All right, I'm going to move featured chat to my other screen. I'm going to get my preview over here so I can see everything. Get that moved to my other screen. I have a confidence monitor just above here. I do have a multi-stream chat widget. I just need to embed it over there. So, Jose over in YouTube, I don't mind answering that real quick. What's my opinion of the GitHub CoPilot plugin service? GitHub CoPilot, I like what they're trying to do with it. It's great for folks that are learning a language, folks that are building an application. And let's face it, when you're building and you hit the same CRUD, the same create, read, update, and delete methods and syntax again and again and again, to have it be able to detect, hey, you're building this, and generate some of that code for you, that's really, really handy. So, and to have it pick up and have it find some of the other code that's in my current repository, and be able to derive and fill in some of the names and derive a little bit of that capability, or even nudge me towards a better way to write my code. Kind of cool. Really cool. The way the plugin is built at this point, it's a little overwhelming for me, because as I start typing a method, it'll jump in and quick give you a suggestion for, well, here's the rest of the code that I think you want to write. And if it's not right, well, now I've got some extra keystrokes I've got to hit to shut off GitHub CoPilot. Otherwise, as soon as I hit tab, because I want to activate IntelliSense or IntelliCode, those other features, instead of it finishing the code that I wanted, which is different from what Copilot is suggesting, it finishes the Copilot segment. So I've almost got to shut off Copilot when I disagree with, when it's given me something that I don't want to do. Escape, stop that suggestion. Let me write some other code. So we're very early in the preview process here. It's still in a closed preview. So, I mean, this is the feedback that the team is taking, and they're working through and trying to make it better. And they want to hear our feedback. The GitHub team is very open, and they about the feedback that they're getting and how they're working through it. So, providing that feedback, those suggestions, is only going to make this service better when it goes wide and is available to the public. Hey, it looks like you're trying to write an application. Would you like some help with that? I would love to have Clippy show up in Visual Studio Code. It would be kind of neat. Yeah, Copilot does still need human interaction. You're not going to be able to just say, hey, generate a repository for this, and it just generates. No, it's not going to do that. Hey, generate a user interface that does this. No, it's not going to do that. But when you start defining, great example yesterday, I was working with, I was building a user management screen. So I'm writing the code that creates a new user and create the code that defines roles. Well, as I started doing the role definition, it auto-completed the code to assign roles for me. Really cool stuff. The big feature that Copilot is missing is that it will suggest code that is invalid. It derives and suggests things, but it doesn't necessarily check with the compiler before it suggests. That's a big hook that it needs help with, right? Don't suggest code to me that isn't valid. That's a problem. So it's getting there. It's getting there. You read somewhere that .NET is cross-platform. We were just talking about that, Shamil. You have a WPF app. Will I be able to convert it to build for Linux and Mac? No. WPF is Windows Presentation Foundation. It's a Windows framework. But you can take the business logic there, bring it into a class library that will run on Linux and Mac. And when .NET MAUI is complete, you'll be able to rebuild and take some of that XAML as well and toss it into a .NET MAUI application. Reference that same class library, and you'll get it to work on Windows, Mac, iOS, and Android. And there's community folks working on a Linux runtime as well. No, you didn't miss the Clippy stream. I got the last parts of the Clippy costume. For those of you that don't know, in May, I was raising money for St. Jude Children's Research Hospital. As part of the milestones, I promised to dress as Clippy, our favorite paperclip friend, and deliver a session. But I wasn't just going to put on some sort of costume that looks like a paperclip. No. I have a chroma key suit. I have giant googly eyes. And I have, it's going to be amazing. You're going to be able to see right through me because I do the chroma key. I drop out my background. You can see where I don't quite have it right over there. Anyways, that's going to be coming up. I need to just finish tying together all the pieces of the costume. So coming very soon. So yes, Shamil, you're going to be able to build applications, desktop applications for Mac. Linux depends on community interaction and how quickly that gets through. Let me see. You're a system engineering student. What is the most used language today? JavaScript, because it's in every browser. Every website, in order for the website to run, has to have JavaScript. However, what's the fastest language out there today to build a web application, to build console applications, to build services? CSharp. You're going to get the best performance out of that, the best bang for your buck, because nobody really wants to write assembly or C++ code to build those types of things. You can do it, and a lot of game programmers do that, but the bang for your buck, productivity-wise, CSharp. Yeah, Avalonia is out there as well. That's another community framework that you can use that'll get you there. No, CoPilot's never going to replace developers. That's ridiculous. Sorry. Blazor versus React. I'll take Blazor every day of the week and twice on Sunday. In 2 short years, Blazor has become an extremely powerful language that you can use on the server, in the web browser with WebAssembly, and you're going to be able to at the 6-month mark, and at the end of after 2 years here. So right in November, you're going to be able to use Blazor to build mobile applications as well. React Native is a completely different animal. It's not quite the same. But React has been around for 10 years. Blazor is very much catching up, runs very, very fast. It's only going to get faster. And as a C# developer, a lot more sense to use. Makes a lot more sense to use. But if you're a JavaScript developer, go for it. Use React. Use what makes you happy. So if you use JavaScript, why not TypeScript? And if you want strongly type something, why not C#? Yeah, great points. Dark mode in Management Studio. You're asking the wrong channel. Management Studio is not a product that we manage. Nor do I manage anything around exams. So Blazor versus Angular versus Vue. Look, Angular and Vue. I answer this question about Blazor every second or third time that we have a stream about Blazor. Angular and Vue have been around for 10 years. Blazor's been around for 2. It's getting there. But in 2 short years, the tooling is better, the development experience is better, and the performance has gotten significantly better with Blazor, and it's only going to get better. It's only going to get to be a better development experience. Get on the bandwagon now. Is it possible to create a game for C#? Check out the Unity framework. There are folks that are building games with that 3D designer. Pokemon Go, that's a Unity game. Hearthstone, that's a Unity game. There's a bunch of them out there. The folks on the Unity blog will tell you all about some of their customers that have been very successful with Unity. And the folks at Blizzard Entertainment, they use C#. They use the debugger inside of Visual Studio to work on Diablo 4. That we had a blog post about that a few months ago. Busy converting from React and Node to Blazor and WebAssembly. Any advice for best path to take? Chris, no, I'm sorry, I do not. What's the best technology for building cross-platform GUI apps? Come on, you're talking to a guy talking about C#. It's going to be .NET MAUI is going to be my answer, but come on. We're going to get into some coding here in just a minute. Hot reload feature is awesome. Let me see here. Yes, WPF is very much still alive. Diablo 2 remake is coming soon. Yes, from the folks at Blizzard Entertainment. All right, let's do this. Let's get in. I've got, yeah, we're on schedule here. I have a sample. I have a I have a brain teaser that we're going to talk through. We're going to look at around values and numeric types, and then we're going to get in. We'll build our first very simple Roslyn analyzer. Talk through all the pieces of it. Actually, I have the sample already built, but I'm going to talk through and show you all the pieces of it and how to get started with that. So let's do this. Let's head over. Rob Lang Dev, that's what IntelliCode does, combined with editor config. That's exactly what it does. All right. Let's get ready to head over to the code. I got to bring my phone, so I have my timer with me. And yeah, let's do this. Let's head over there, and we'll take a look at the GitHub repository and do a little brain teaser to warm ourselves up before we dive into writing a Roslyn analyzer. So let me head over there to the other screen. Why switch to the headset mic? Because I don't have a microphone over here. So I can walk over here, I can walk around and be able to see everything that's going on, including the live chat over on YouTube. There it is. And I've got that. Very good. Very good. There you go. This is my Surface Book. It's this machine right here. I've also got I have a Chromebook sitting over here so I can keep an eye on chat from YouTube, and I've got my Confidence monitor over here. It's not really a stand-up desk so much as it's a high-top table that I've got set up with a bunch of machines on it and mices. I got a brand new. I went to the electronics store this weekend. I went to Best Buy, and I picked up a wireless keyboard mouse combo that I wanted to use over here so I could control and get back into chat and move my mouse and all that stuff over on the main streaming machine on the other side of the home studio here, but I just didn't quite get it wired up yet. So what sort of analyzer? We're going to write an analyzer, very simple analyzer that analyzes block code structures and interacts with them. So, all right, let's do this. No, C# does not have a dependency on .NET Framework. It has a dependency on .NET Runtime. So, all right. So, Here's the GitHub repository that we typically work in, C# with CSharpFritz. And you'll see 0504 is the branch that I'm going to be working in today. We had a question a little bit ago about, hey, how do I run Jupyter notebooks with C# in the browser? I have a handful of notebooks defined inside this folder. There they are. But if I want to run them in the browser, I've wired these up so that you can launch them with a service called Binder. And Binder, let me open that in a new browser. Binder will start up, instantiate a Docker container, and point to that notebooks folder and have all that code lined up, have the .NET interactive tools all configured for me so that I can start writing .NET code and interacting with it inside my browser. I'm trying to think, which one is it? I thought it was, is it that one? I think it's that one. No, it was over my shoulder, it was over, whatever. Because I'm looking here and thinking, well, I thought I had the curtain all the way laid out here. So this is going to take a few seconds to start because it's downloading a brand new copy of that container to launch, and you can actually watch it right here, launching. So, here we go. There it is. There's my content. Really, Cam? That's kind of annoying, that many underscores. So, these are all the notebooks for the first 9 sessions that we had here live on stream. So I'll just control-click to open one of them. And here's the Jupyter notebook. All kinds of information about getting started with C#, syntax, and even code that you can run here live in the browser. And it executes, and it'll just drop out 10, right? I mean, these are simple examples for getting started, and we're going to get back into some of these getting started samples later in August. We'll be back involved with that. So if you want to jump in and tinker with and learn more about these, you can either click the Launch Binder button right here in the GitHub repository, or clone the repository, and you'll be able to open those notebooks up inside Visual Studio Code. There's support for it there. It'll install all the appropriate tools for you, and you'll be able to start running some of those samples live in the browser. So that was to answer that question from a little bit earlier about running C# in the browser. All right. Cool. Getting in a little bit further, I want to go to, where is it? No, we won't run from over there. I'm going to go open my PowerShell. And let's open another PowerShell over here behind me. You know what? Do I not have that? I thought I had those samples here. C#. Yeah, there it is. Yep. Let me open Visual Studio Code here because I have the brain teaser that we're going to talk about today to get things started. I have this built. It's a little puzzle over here, and it's called Top of the Type. And good, all of my outputs are cleared. So let's talk about, right, and this is why this is an advanced session, right? There are these types of things that you need to know as you're working with C#, as you're working with .NET programming languages, where the behavior of things, when you get to the edges of typical objects, typical interactions, things don't quite behave the way you expect them to. Let me show you. So if you're working with those standard numeric value types, right? Integer, double, single, decimal. What happens when you attempt to store a value that's one more? That's just a little bit bigger. You'd think there were some errors that might raise. You'd think there'd be, right, some sort of sirens that go off. Oh my gosh, you're doing something wrong. Maybe. Not all the time. Let me show you. So let's just console write line to start things off. Let's just write out int max value. So I'll control enter there. And of course, 2.1 billion, right? And some folks have this number committed to memory. It's 2.1, right? 2.1 billion is that. And that's easy for us to remember and interact with. But if I scroll down a little bit here, oh, that wasn't what I wanted to do. It was this one. There we go. So what if we take that max value? Let's assign it to a variable top, and let's add 1 to it. So 2.1 billion. There it is. It's still right there at the top of the screen. Let's add 1 to it. What do you think it's going to be? 2.1 billion. Let's add 1. What is the integer going to report? Yeah, we're going to get to checked a little bit in a little bit there. We'll talk about checked in just a minute. So, what do you think the value is when you add 1 to that 2.1 billion and stick it back into an integer? Is it going to return 0? No, it's not 0. Is it, right? Is it going to be, right? 21474836648. Well, first off, I'm getting a red line indicator. Can implicitly convert. It's a little bit bigger than we can fit into an integer, so it's not that. So what? It's not 0. It's not that. What's the value that it's going to report? We're going to talk about checked and unchecked in a minute. We'll talk about that. The lowest value, the minimum integer value. Int min value. Yes. Why? Why do we get the minimum value? You added 1. Why did it turn around and give us that? It wrapped around. Integer can only store from negative 2.1 billion to 2.1 billion. So when you added 1 to it, well, it reset the value. So instead of it being 2.1 blah, 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 it rolled around and went back to its minimum value. And that's what's happening there. So it's a little bit of a numeric overflow is what's happening there. It's a binary value, and you added 1 to the end of it, right? It's fox, 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 fox. You added 1 to it when it flipped everything to zeros. Well, that 0 array, binary array, turns into the negative 2.1 billion. So let's take a look at double. The maximum value for a double is 1.79 times 10 to the 308th. That's a big number. That's a really big number. Where'd it go? What happens when we add 1 to it? What happens when we add 1 to double? Does it give us infinity? No, it's not infinity. Did you even know there was an is infinity method here? Right? No, it's not giving us that. What's going on there? Do strings have a maximum also? No, strings do not have a maximum. You can store really big strings. They're pointers to character arrays. So what if you subtracted that? Will it go to the maximum value? Seth asking an interesting question on YouTube. If we go back up here, what happens if we take int min value and we subtract 1? Right? Look at that. Now we overflow. In checked code, now we overflow. Okay. All right. Right. And even if we do that here, yeah, I could. So you're going to see this problem. So adding 1 is not infinity. In fact, adding 1 to a double. Wait a sec. That looks familiar. It's the same as this value when we add 1 to a double. Why? It adds 1 because double precision is only so precise, right? It's only, what is it, 32 bytes? 64 bytes? Because it's only that big, 1 is smaller than the precision of the double. It doesn't matter, right? It doesn't know what that is. It doesn't care what it is. It's outside the precision of the double. It effectively ignores it because the value is so small compared to the value that you're working with. That's right. 1 is insignificant, Chris. Yes. If a string is a pointer to a character array, would the length of the array ever exceed the max integer value? Would the length of the array? No, because it would turn into a long. And you would run out of memory. So, okay. Does that apply to decimal type values as well? We'll look at decimals in just a minute. Spoiler alert! So, let's take a look at single values next. Single precision. So, single precision, it doesn't go to the 308th, 10 to the 308th. Instead, it's 3.4 times 10 to the 38th. Okay, that's the maximum value there. If we take that value, and if we add 1 to the 32nd, 1 times 10 to the 32nd, right? So effectively, we flip that 3, right? Because now it's precise. Now we're adding a value to that is in the precision of a single. What happens if we add that to it? Is that infinity? Or is it something else? Well, taking a look here. Eggsy, hello, good to see you. No, I'm not going to go into the half type. No. Not sure what 1E32F is, so that's 1 times 10 to the 32nd is what that is, Jelly. You've been learning C# through the YouTube videos. Well, thank you so much for tuning in. I'm very glad that you're enjoying the videos here on YouTube. I'm not going to give my... there's a whole language designer team that's discussing the future of C#. Once a month, you'll see them on the .NET YouTube channel, on the Visual Studio channel on Twitch, and they'll be happy to talk about the futures of C#. I can tell you the team is innovating and constantly building new features into C#. C# 10 is coming in November, and it's got features in it that support some of the new that were built specifically so we could do some cool new things with some of the frameworks like the new .NET minimum APIs, but you're going to minimal APIs, but you're going to see more investment in C# and new versions of C# with new features that make it easier and better for you to write code every year, every November for the foreseeable future is what the plan is. But my opinion of it, it's only going to get better. You want to dig in further? I suggest you talk to the language designers in their sessions because they're more than happy to dig in and talk about all kinds of features and some of the proposals that are out there that are happening. So, yeah, the F on the end it indicates that it's a float. So if I add 1 times 10 to the 32nd, it becomes infinity. I've pushed single beyond its size, and instead of it doing some sort of an overflow, instead of it coming back and saying, ooh, I don't know what to do with that, it comes back and it turns into infinity. That's interesting. That's really interesting. Are there places in your code where it makes sense to work with the constant, that sounds weird, the constant infinity, right? And in fact, there's even, right, it'll even give you the little infinity symbol here when you say write out that value, and you get the little infinity symbol output there. So we had a question about, well, what happens when we do this with decimal? What happens if we increment decimal and we push that? So the maximum value for decimal is 7. Oh my gosh. I can't even read that entire number. That's a ridiculous size number. That's a big number for a decimal. Okay. Notice it's a whole number also. Well, if we scroll down here, what happens if we add 1 to it? For a decimal. We had this question over in YouTube chat. Let's add 1 to this. That's right, Jellytin. 10 to the 32nd means 10 times 10 times 10, 32 times. You can also think of 10 to the 32nd as 1 with 32 zeros next to it. So, yeah, Chris just mentioned that right after it. You got it. Yep. So, that's something that you'll see in some math classes. It's slower than double, but is irreplaceable for the execution. They're not. Working with the different value types should be the same speed, because it's just different shapes in memory that you're working with. I don't have anything to back up, but I don't think that it's slower. It's smaller. So, yeah, when we add 1 to a decimal here, I see the guess there. I'm actually going to get an overflow. Now I get the error that value is too large or too small for a decimal. Now we've broken it. It's interesting that we didn't get this on our other numeric types. That's important to know that doesn't happen. Now, if we use the checked feature to enable that overflow checking, now, right, arithmetic exception occurs in an overflow. But if we move that out, put that into another method and call it. So calculate number input plus 1, and we take it, if we take the max value and we say int next, now we wrap with checked. Now the checked feature, let me bring that up. Where'd it go? If I navigate to, you gonna open in a browser there for me? There it is. The checked keyword is used to enable overflow checking. So this is going to enable that checking. Otherwise, it's not going to do it. Now, the notebook, the .NET Interactive notebooks have this kind of turned on by default. But if we move things around a little bit here and we put our checked statement around calculate number, and now we interact with it, now, right, we still get down to that negative 2.1 billion. So, some things for us to know, some things for us to understand as we're working with numbers, numeric values with C#, because it can get a little crazy. It can get a little different. It's not something that you expect when you're working with these types. And if you know that those things exist, as you start pushing the boundaries of some of those value types, if you don't want to get into that weird behavior, change data types. There's a point where it makes sense not to store a number, but instead store a string, store an array of characters, because are the numbers actually significant as numbers? Okay, maybe if they are, turn it into an unsigned integer. Well, now you just doubled the size of, you doubled the maximum number that you can work up to. Maybe maybe you don't need all of that precision. So maybe double makes sense or single makes sense for you to work with. But there's some interesting things that happen as you get to the far right of a number, particularly a double or a single. We can talk about that in another puzzle that I have out here for you. Let's talk about building your first analyzer. So why would you want to build analyzers? What is an analyzer? Why does this make sense? Who's doing this? Why? Why do I want to do this? Analyzers are bits of code that analyze the code that you've written. These are static analyzers. They're not analyzing running code, but they're analyzing the syntax that you've typed. They're not executing. They're not working through and analyzing how much memory you've used. They're not analyzing how much processor is in place. Those are different tools that'll help you with performance. This analyzes the code, what you've written for humans to be able to see, and allows you to be able to provide recommendations for better syntax, cleaner syntax, standardized syntax that maybe you want all the folks working on a project to adhere to, so that you don't fall into some common mistakes, do some common traps, right? Maybe there's a common naming convention you want to enforce, or right, a common code structure you want folks to be able to work with. Maybe you want to say to folks, you know what? We never work with Entity Framework directly in our ASP.NET controllers when we're building and writing APIs. We don't work with Entity Framework directly. Instead, we use a repository. We use something to abstract and redirect. You can write an analyzer that will check to see if Entity Framework is in use and raise an appropriate error message or a warning. You can stop the compiler. You can stop the compiler and say, this is an error. I'm injecting and telling you, compiler, that this is not valid by my rules that I'm defining. This is a way for you to tell the compiler to create new warnings, new informational messages to raise, new errors that you want to use to curve, to shape how you want your development process to occur. And like I said, this is great for kind of enforcing design standards, coding standards, and make sure that everybody is writing similar structured code. Now, some folks look at that and say, you're taking away my freedom. I want to be creative. I'm an engineer. I'm a programmer who always writes perfect code. Sure you are. Sure. At some level, you have some sort of a syntax, you have some sort of a standard, you have some sort of a typical structure that you're using for your code. And you probably want folks to be able to write applications similarly. Let's face it, when you look at an application that had a team of 15, 20 people working on it, and they all had different techniques for how they wrote things, and you can see exactly how Skippy wrote that method over there in that class, and Alice over here, she wrote a bit of code to work with database, and it's completely different from how Skippy wrote that class over there. That's a pain in the neck to juggle and understand and keep straight in our heads as humans. The compiler knows how to deal with that. We don't have to do anything to teach the compiler how to interact with things. The compiler knows how to write code, knows how to read code. It's just fine. But for us as humans, to be able to work with other humans and be able to pass that knowledge back and forth, analyzers are going to get you there and help you be a little bit more consistent in working with some of those folks. All right. Yeah, the perfect programmer. That's right. There's no such thing as a perfect programmer. All right. So I did the brain teaser here. Now, you'll see out here on, let me open the link. That's the other Visual Studio Code. There we go. This is the Roslyn Analyzers repository here. There's a bunch of analyzers here, some assets, and some tools for building and working with analyzers, how this all fits together. It's a compiler Roslyn is the compiler platform for .NET, consists of the compiler itself and a powerful set of APIs to interact with the compiler. And that's what we're going to use, is those APIs to interact with the compiler. So analyzers analyze your code for style, quality, maintainability. I just talked about that for a bit, probably for too long. And there's a series of analyzers that are available for you here that you can download and use in your projects. And there's different indicators here for whether you should use these, whether they're approved, they're recommended. And some of these kind of ship with the default templates, with the runtime, with the projects, so they light up automatically for you as you're building and working with your projects. Particularly this first one, Net Analyzers. Primary analyzers package for this repository included with .NET 5 and later. And there's ways you can turn this on for earlier versions of .NET Core, .NET Framework. There's capability there. Banned API analyzers allows banning use of arbitrary code. Okay. That's kind of neat. Public API analyzers here, right there. Helps library authors monitor changes to their public APIs. That's cool. That's something I may want to bring into another project that I've written that interacts with public APIs. And when those APIs start changing, be able to reflect and go through my code and get information appropriately about what I need to fix. And intended for projects providing analyzers and code fixes. That's Microsoft Code Analysis Analyzers, Roslyn Diagnostics Analyzers, rules specific to the Roslyn project. So for those folks that are building the compiler, these are rules for how to build the compiler. That's the type of team-specific, hey, these are our standards. You need to adhere to this. This is what the compiler team uses to enforce for building that. And there's some deprecated ones here that some folks have used for a while. FX Cop analyzers, code quality analyzers, net core analyzers, and this last one down here, net framework analyzers. They've all been superseded with the new net analyzers project. And there's information about that right here. So we can put these into our project and it'll recommend all kinds of different things for us to do to improve our code. So let me go over to here. Let me hide that for right now, but I will go to Solution Explorer. I have a simple project. There's the analyzer we're going to be working with that analyzes usage of braces inside our project. But here's the analyzers, net analyzers right there. This is where you would see it inside of Visual Studio when it runs. Now, these are going to be running in the background inside of Visual Studio Code so that you get that feedback inside of your application, and you'll see the feedback from the analyzer when the little light bulb icon appears in the gutter on the left side of your code. So, right, if I take a look at this, see the little light bulb that pops up there, and if I pull that down, it's already suggesting that that's actually the analyzer that I'm going to be building here to add braces. So it's giving me a hint. It's saying, hey, you may want to add braces here to make it clearer that this thing needs to be fixed. This thing needs to be addressed. Okay? And it's got a style rule here that we can click through, and it has a description of exactly why that rule should be enforced. But and you can see there's another one up here that lit up. So there's information here about, here we go, code style, severity. We can set that. This is all a style thing here that we can interact with. So there's different levels of error reporting, of why and when you use an analyzer. Do I use the analyzer as something that gets delivered with my project? Or maybe the analyzer is a feature that you've installed with Visual Studio so that just your instance of Visual Studio, not everybody else's, but just yours, enforces certain rules. We can build and deliver that as what's called a Visual Studio extension, not Visual Studio Code. This is a Visual Studio extension. So it's specific to your machine. So what we're going to be doing now is we're going to generate an analyzer. We're going to build this first one so that it reaches in and looks at these statements that we have right here, where yes, this is valid code. While 1 does not equal 0, if true, console write line. So this is going to forever, right, just infinitely write out this is a test. But it's not clear to our human eyes. The compiler sees this and says, oh, okay, while, well, there's no braces around this. So that means while I'm going to do the next line. Well, the next line is if, and there's no braces. So that if says, well, if this is true, and it's hard-coded to true, then I'm going to execute whatever is the next line because it doesn't have braces. So it's going to be console write line. So it's very easy for us to look at this as, because it's indented and we can see, okay, I can derive that that's what happens. But where it becomes kind of confusing is if I go down here somewhere and I say console write line, this will never run. So the problem that we've created here, and the editor is helping me. Don't help me. I want to show the mistake here. Because I added this second line to our human eyes, because it's indented at this level, it looks like it'll also run when that if statement is true. But it won't, because the if statement doesn't have the curly braces around it. So that's the justification for the analyzer that we're going to build. And make that clearer. While this syntax is legal, it's nice and terse, I can read it quickly, I would prefer it to be on one line. If you really want to use this type of one-line if syntax, put it on one line, right? If you're going to put it on a second line, wrap that in braces. Make it clear that that should be a block-level statement. Yes, and look at that. Visual Studio is telling me that's unreachable code. It's never going to reach that. See that? So this is the problem that I'm going to show you how to analyze and figure out how to put a little bit of code in here to suggest this. Let me take a look here at chat. Wanadza asked, do the analyzers happen during compile time? In other words, do we tweak the build engine, asking in the context of CI/CD, where we have shared build machine agent runners? Great question. So I mentioned there's two ways to deploy an analyzer, as a Visual Studio extension, and you can also deploy it as a NuGet package that the project references and consequently is able to use wherever the project is being worked on, including CI/CD. Now, in the new versions, I forget which version they turned this on, but the analyzers will run as part of the compiler, and you will get feedback from them if they're set to an appropriate error level. You will start to get their output. So that becomes a great thing for us as developers to be able to set configuration and say, this is an error. Break the build if this rule is violated. Now, you can set the default level inside the analyzer, and I'll show you where that's configured. And you can also define that level inside of the project, inside the project file. So, right, and I'm going to be showing, where is it? Come here, you. This one right here. Right, the add braces here. Suppressor configure issues. You see this? So this is a feature that lights up in Visual Studio so that you can tell it, well, what severity would you like it? Or, you know what? Ignore it altogether. Right? So I can go down here and say, you know what? We can add an entry to editor config. We can configure severity for all the style analyzers, code style analyzers, for all analyzers over here. But the add braces, I'm going to make that not a none. I'm going to make that a warning. So now, when this project builds, And yes, unreachable code. Come on now. Yes, I know that. I thought, go back. It put it in editor config, thank you. Over here, yeah, net 5. Why is it saying? Come here, you. I should be seeing that error being dropped in here, and I'm not seeing it, of course. Of course I'm not. Tell you what, I'm gonna go right into the shell over here. You over here, go away. Really? Thank you. Test project. Yep, console app 1. There it is, console app 1. And now if I .NET build, I should get the analyzer reporting here. There it is. Unreachable code detected. No, it didn't. It's not raising the analyzer there for me. It's supposed to be doing this. It put it in. Come here, you. Go back over to Program CS. Suppressor configure issues. That's a code style. Fix formatting. And I thought I could turn these up to errors and it'll start breaking the build. That's not right. Come here, you. So now, do this again. Since I set it to an error. Yeah, build succeeded. Now I'm confused. It's supposed to be breaking that. Because I set it to an error. So I can see the full list of analyzers by opening up the net analyzers here. These are the ones that come by default. Come here. Let me get rid of this so I'm not confusing myself. Back up to this one. It put it into an editor config up here. Go back to that one. So editor config, this is available and is used. Stop that. I wanted to see the actual code for that. Yeah, open with the text editor. It's not JSON. I want the text editor. Whatever. So there's... See, that's not even the one that I thought it was. No, hang on. You, go away. Try this again. So here, if I open that up... No, it's still not showing me the full thing. Oh, geez. This... Configure the code style. Yeah. But it's doing that as a code style, not as the analyzer. I'm going to back out of this. Because that's not what I wanted to get into, and I'm going down the rabbit hole away from what I wanted to work on. Yeah, analyzers. No. They should have been... I thought they were triggered inside the build file. Delete that. See, and there's one over here now, too. No matter. Let me get in and actually get into the analyzer here. I'm getting off topic. I'm getting away from where I want to be. But yes, you can suppress the interaction. So you should be able to. I thought you were able to, and I could have sworn I had seen it running. That that it interacts and can break it. I don't know why it's working. All right. So the analyzer that we're going to build, this is actually comes out of a blog post that Mika Dumont wrote. Oh, I should show the prerequisites. All right. Let me show the installer. So in order to build analyzers, you need to have the tools installed with Visual Studio that allow you to work with the compiler SDK. This is the only way to get the SDK installed. So there are a couple pieces that you need here. There we go. Now I can see the entire installer here. So you need, where is it? I need desktop application to start. There it is. .NET desktop development. I need, scrolling down here. There it is. Visual Studio extension development, so it knows how to build those pieces that you want to install into Visual Studio if you want to deploy that way. Also over here in the individual components, you need to look this up. It's right there, the .NET compiler SDK. This is what will allow you to build and work with the analyzers. So I've already got those installed here locally. So I don't need to run through and actually do that compile process. But the blog post that I'm taking this from, this demo from, is here from Mika. And it's from about a year ago. Talks through all the installers. And we're gonna, there's the sample that I showed you, and we're gonna build this little analyzer that's going to encourage you to build braces better into your, use braces better in your code. So I've already got the code written over here for this. I've already got it all set up so that we can go through and actually talk about this. Now, when you go to build a new project, a new analyzer project, so I'm going to say File, let's say Add New Project, you're going to want to build an analyzer project, and that template is in here. So if I just search for analyzer, you'll see I get two templates that pop up. Okay. This one here, analyzer with code fix, .NET standard with C#, and there's another one here if you want to write it with Visual Basic. Your choice of programming language, you're going to generate the same content out the other side. So I generated mine and I called it the Brace Analyzer, and that's the name of the first project here. It generates 5 projects in the solution for you. Now, and when you see, this actually feels like a good separation of content for you. So I have my Brace Analyzer. I have my Brace Analyzer code fixes. So this contains the code to repair those things that your analyzer has detected. So your analyzer is going to raise an alert, right? It's going to say, hey, there's a violation that I've detected over here in code, and you want to provide an appropriate fix for those things, and that's what a code fix is. So we have a project that contains all the code necessary to fix what's been detected. There's a packaging project here, and that contains everything you need to ship as a NuGet package. Now, the install and uninstall scripts here, you can go through this and add other entries here if you need to configure other things that need to be delivered with your analyzer. For the most part, if you're just delivering the analyzer with the code fixes, don't touch this. Go into the project file, and there's all this configuration information in here for how you want to configure your NuGet package that's going to be available from NuGet.org or whatever package repository service that you might use. You can configure all the information in here, the package ID, the version, the author, your license, project URL, blah, 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 blah. You see all the tags here, real easy to fill them in and configure them appropriately so that folks can discover your NuGet package and get it installed on their system. Okay, so that's the package project. The next one down is the test project, and this contains a whole bunch of stuff so that you can unit test your analyzer. And I've had a devil of a time getting this working properly for this demo. I'll update the code there, and I'll have it available in the repository with a working test for this sample, but for some reason it's just not working the way that at least the way that I think it should be. So I'm going to get some help and get that cleaned up for later. Finally, there's the V6 project that you see down here. That's what's going to package and deploy and make your analyzer available as an extension inside of Visual Studio. So you can deliver this V6, either put it out somewhere on your company's, your organization's, on your intranet, somewhere that folks can download and install it. You can publish it out to the Visual Studio Marketplace if you'd like, so that everybody can get this really cool analyzer that you're building and be able to clean up their code and take advantage of your coding style. This is sitting here with a manifest and configuration so that, and there's a tool here. There's a visualizer that it will give you here, and I'm not getting it to open for me, that will help you, right? Yeah, open with, come on, show me, yeah, the manifest editor, that one. You make me sad. I am running a preview version that should have opened in the manifest editor, but instead it's opening the XML here. Because there's a whole bunch of things you configure in here to configure how the Visual Studio Marketplace is going to see this and how Visual Studio is going to see this so that it gets configured appropriately. I'm not sure why that didn't load properly. They are doing a lot of work on the extension configuration for Visual Studio, particularly as they're getting ready for Visual Studio 2022. I wonder if it's just not working correctly there for this. Let me take a look back at chat real quick. Cool. We're okay over there. All right. So let's talk about how we're going to analyze and bring this information out. So I'm going to start by looking at the analyzer code that's actually going to analyze my code, right? This is going to read, the compiler is going to read my code and bring back an appropriate error message for me. So let me close up the Solution Explorer there, and right away, most of this code you're seeing here was generated for me by Visual Studio, and it's a lot. It's a lot, but it's actually not that overwhelming because they put some nice comments in here that are going to lead you in the right direction. So we get a diagnostic ID. What do you want to call this? What's the identifier for this analyzer that we can convey to the compiler? All right, so I'm calling this Brace Analyzer. And then I have a title, a message format, and a description. And these are listed as localizable strings. It's one thing to have the title and the message and the description about your analyzer that appears on screen. It's one thing to have them as strings. That's nice. But it's even better if you make them localizable strings, because then we can translate them. Then we can provide alternate representations for them for appropriate other human languages that we want to convey information about. So I have sitting here inside of the project, it by default comes with a resources regex, and you can provide alternate resources in alternate languages, and it has this nice grid that appears here. This is in an ugly XML format. If we take a look, if we peek under the hood here at the XML, it's got a ton of comments up top, and then it's got a schema. And finally, after we get past all the schema stuff, there's the actual data that configures the messages and some of these strings for our project. And this is a standard regex format for .NET. I'm not, with the advent of other formatting languages, I'm not a fan of this for something that I want to pass along to somebody who might not be a .NET developer to help with translations. There's organizations out there that know how to generate and translate and can help you with building this format, and they're great at their job. But if I'm passing this on to somebody who isn't a developer, I don't want them to have to deal with this. Even though inside of Visual Studio, you get this nice grid to work with, I'd really like to give somebody who's non-technical like an Excel sheet to fill out, right? Here's the spreadsheet. Here's the terms in English. Here's the label that I use. You know, put your language in this next column. I'd like to have that type of interaction because that's what you get here in Visual Studio. You get that level of description and definition of what we want. So I have these three terms: analyzer description, analyzer message format, and the analyzer title, and there's the English for those. Hey, enclose statements with curly braces as the description, as the title, and I've got a message format that says we're looking for a brace. We're looking for that to appear inside your code. So you can put the hard-coded values here, and look, you can see it's going into name of, resources, and getting that key using the resource manager and writing it out into those. Okay, I specified block statements as the name of the category that I gave this because I want to define, well, maybe there's a whole bunch of things that I want to use to format statements, block level statements correctly, like if and while, right? I want to get those all configured the same way. All right. So then we have, and I still haven't hit my code that I wrote. In fact, my code's in this initialize block. So we have a diagnostic descriptor. This is the rule that we're defining to work with this project, this analyzer. So we're going to take in that diagnostic ID that we defined up here, brace analyzer, right there. Let me put a carriage return in here just to make it a little bit easier for us to see this. So it's all on one screen. Because there's a lot here. There we go. So diagnostic descriptor. So we call this the rule, and it's got the diagnostic ID, brace analyzer, we called it. It's taking that title, text in, message format. This is all the stuff to configure how it's going to appear inside the editor, okay? We have an array, a collection that we're going to output of the supported diagnostics that this class supports. And it supports just that rule we defined, the brace analyzer. You can have this define and support several different rules. You can put them all in this one class. For the purposes of organization, it might be better to put one rule per class just to make it a little bit clearer what's being enforced, what's being worked with there. It's up to you. You can structure that however you'd like. Now, the method that's actually doing the heavy lifting, that's doing the work, is this initialize method. Let's take a look at this. So it takes in, it receives an analysis context. This, thanks, enables concurrent. There we go. This is the context for initializing an analyzer. So it will register and can hook up to actions like compilation start, compilation end, completion of parsing a code document, blah, 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 blah. All these various events that you can connect to and start working with, okay? And we're going to learn what some of those nodes are in a minute. So we're going to register a callback, a method to be executed for some interaction with the syntax tree. Now, the syntax tree is when it's parsing, right? That's the entire structure of the code document. So it's going to report diagnostics about the syntax tree of the document to us, and we're going to be able to interact with them. So we're going to iterate through all the statements in the tree. So take the syntax tree context, take the entire tree, the entire structure of our document. We're going to go to the root of it, and we've got a cancellation token in case it takes too long. We can stop. So, or if the editor is closed or something, that token will stop that interaction. For each statement from the root, taking a look at the descendant nodes of that block of code, we're going to look for statements. We're going to look for statements that are in there. And if the statement is a block statement, continue. That's fine. It's a block. Go ahead and continue. But if the statement parent is also a statement and the statement parent is block syntax, is not block syntax, then we want to raise, then we want to interact and say, this is wrong. There's a thing here that we need to interact with. Now, before I get into the diagnostic and raising all this information, how do I know anything about that syntax? Let me go back to my program over here that we started with that we're going to look at. There is a syntax visualizer that I need to restart here. And I'm going to go, it's View, Other Windows. There is Syntax Visualizer. And it's still not going to run for me here. You make me sad. Close that, come back over here. Bring that up. Come on. Nope, I'm going to need to restart Visual Studio to get this to start appearing. That's okay. Not a problem. Save it. I will restart it. The syntax visualizer has been a little grumpy for me today. So let me reopen. And it's going to tell us the structure of our code, the way that the compiler sees it. So then we can start talking about how to navigate around this thing. There's the syntax visualizer right over there. So wherever my cursor is, it's going to tell me information about this. So look at this. Look, it starts with a compilation unit. Well, the compilation unit is this file, program CS. It sees a couple using directives. It sees a namespace declaration. Then it sees a class declaration. There it is, namespace class. Inside of the class, it sees a method, right? So yes, there's our method main, right? If I click on that, it highlights, that's what it sees. There's a method body inside of here, okay? And some block context. And if I click on the while, right? So here I am inside the block for the method. There's the while statement. And in fact, it sees the while keyword because I've highlighted that, right? So if I just click over there, right, it's even telling me that it sees that white space. Whoa, okay. So now let's apply what we're learning from the syntax tree to actually looking at the code over here. So I'm just going to put that away for a second, right? So I was looking at statements that have a parent, but that parent is not a block, okay? So let me go back to program. Let me reopen the syntax visualizer. You're really going to be this ornery with me today, aren't you? There we go. So here's my if statement, right? It's an if statement, and its parent is a while statement, and the parent is not a block, right? Because if this is a block level statement, because it's got the curly braces around it, right? I'll go back to that if statement right there. If statement. You see, if statement, its parent is a block, okay? So this is the behavior that we want, is that. We don't want, right? That, where the if statement isn't. This is all valid code here, right? And the Roslyn syntax tree visualizer here is telling us, showing us valid code, but it's showing us that this the parent of this is a while statement. We want that to be the block. All right. So how do we fix that? Right? Let's report that information out. See that in the syntax visualizer just disappeared again. Yeah. Delete that. Delete that. There we go. Save. Okay. So the analyzer over here, we're going to create a diagnostic report for this. Hey, you don't have the syntax right. So diagnostic create the rule, and the rule is what we created up here. Where'd it go? There it is, right there, right? The diagnostic descriptor explaining here's what it is that we're telling you you need to fix. So back down here. So we're going to create a diagnostic message to report based on that rule. And what are we going to highlight? What do we want to tell you? What do we want to actually drop in there so that you know what you need to fix? So, right, check this out. Let's bring up the IntelliSense for this. So what's the location? It's the optional primary location of the diagnostic. If null, it'll return location none. We want to tell it, go find that first token of the statement that doesn't have a block, right? So that if statement inside the while, go find the first token, if or whatever that first word is that we've written in code. Get the first token and get that location, and that's where we want to put that squiggle, that underline, so that for us as humans, we know there's something there we got to fix. So we're going to create that diagnostic object, and on the syntax tree, so that we can get that little squiggle line, that little wavy line to appear, we're going to report that diagnostic. We're going to bring that back right there, diagnostic. Now, up here, we specified that this was a warning. So let's check this out. Let's actually run this now and see this running inside that project. And it should give us a warning for that. So the default project to run is the v6. So it runs the new analyzer in a test version of Visual Studio, and that's why we need the extensions, so we can see that test instance of Visual Studio running that we can interact with. So I am going to start debugging, and it will fire up Visual Studio here for me. Just add and remove a space. Yeah, that kind of refreshes. I have tried doing a little bit of that, but it hasn't always worked for me. So let me open that console app that you saw I had open. All right. Writing the component cache, get everything loaded up here. This is going to have the white, the light theme, much to my dismay. But it'll have my project loaded, and it'll have that analyzer attached, and we can see how it interacts with this. So there we go. And now, if I look at the dependencies inside my project over here, I should see in the analyzers block. No, I don't. It's running as an extension. That's fine. So now when this wires up, there it is. Now you see I've got the green underlines here. And when I mouse over it, now it shows my brace analyzer, right? And when I pull that down, it's actually got some of my code in there also. There's brace analyzer running. I can suppress it. In source, in the suppression file, in source, I can also set its severity. I want it to actually be an error. And that should turn into a red underline for me. There we go. Now it's red underlines. Right? And now if I try to build this, that should block. No, build successfully. But I've got the errors being reported over there. I thought you could get that to block. I'm going to have to go dig that up and update the documentation for this session. So I can also suppress it. I can wrap it in my source code, and this is something that you've always had the ability to do, is be able to say, you know what, ignore this analyzer here, and it generates that code for me. But my analyzer is reporting what I want. Now, the analyzers that you see being reported for some of the standard code that's out there, they do have hyperlinks embedded so that there is a click-through to find and learn more information. You can certainly put that into your projects as well. You're confused. What's confused? Let me know. Let me check over here in Twitch. Hot reload. I don't know if hot reload. No, hot reload won't work on this because, well, that hot reload is different, and it's not available for Visual Studio. Sorry, you can't hot reload Visual Studio. But we can change that default setting over here. We can change some of the message information, and it will load up and behave appropriately inside that other Visual Studio. So let me change the name of this from Brace Analyzer to Fritz's wonderful Brace Analyzer so that it appears the way I want it to. Now, that's great that it detected it, but you already saw a little bit of I want to suggest a fix. I want to give you the opportunity to just right-click and say, go fix this thing. So how do I do that? And that's what this code fix is down here. So this is a code fix provider, and I'm specifying, here's the name of it, and I can specify, here's the title that I'm going to output. And I can say, Fritz says, add braces, right? That's going to be the title that we want it to show. And I'm specifying, well, what are the diagnostic IDs that we want this to apply to? So what are those? Well, I'm going to return an array that includes my Brace Analyzer. That sounds weird. But the project name was Brace Analyzer and the analyzer that inside of it. So now I end up with an analyzer. You get the point. So I'm passing along and referencing that diagnostic ID that we had over here. So there's a block here, get fix all provider. Now, this is for when you have that scenario where it comes up and says, I've detected this problem in a bunch of other places, and you could say, well, here, go fix it everywhere. You can change that behavior. There's a link here with more information about how to do that. You know, for this type of change that we're suggesting, this is just fine. I'm setting this to batch fixer. Okay. All right. So, Curious Drive, there is a unit test project here. I'll show you it. I haven't gotten it to work with this analyzer, and that's something I need to tinker with here before I publish the source code. So they always have this. This is the method that's actually doing the work. Register code fixes async, and it takes a code fix context. Now, it's going to get the syntax root of the context that we're working with, right? So I've got the root of the document again, right? I'm up at that top first using statement inside the file. I want to go find that first diagnostic, right? That area where that first squiggle line appeared, and get the location, get the source, the entire span, that block of text for that diagnostic. And we're going to find the type declaration identified by that. So we're going to go from the root and go find that declaration. Go take this location, which is just a literally rows, columns location. And what we're going to do is, after we find that token, which we saw was the if word, just the word if. And what it's going to do is it's going to say, okay, get the parent and that type declaration syntax and get the first. So it's going to get the while, the statement before that, okay? And we're going to register the code action that's actually going to do the fix. What is the manipulation that needs to be done? How are we changing this text? It's not code, it's just text that we're pushing around. And we've got a little bit of objects here that we can interact with. So I've got the title of that code action. I've got the create change document. So what's the method that does this? Well, right, we're handing this off to a method called add braces async down here. We're passing the context of the document, the diagnostic, the add braces analyzer that was raised, and finally the root, the top of the page, so we can work from there. So add braces is going to say, root, find node, and go find that diagnostic location. Go get that block and go find the ancestor, the statement syntax. Once it has that, now you got me thinking, no, this wasn't used anywhere. No, that was from something else. Yeah, don't need that. That was for the original sample that's in here. All right, so once we have the new root, the statement that we're working from, replace the node, replace that statement that you've identified, and instead, we're going to take the syntax factory object, and let me show you what that is. It's a class containing factory methods for constructing syntax nodes. It's a class for building more code. And we're going to create a block around the statement that we had highlighted. So we'll take that, and we're just going to say return task from result, document with syntax root, new root. So we've replaced that element here. We've replaced it. And we're returning that new document, that updated document, back into the code fix here. Real easy to follow. When you break it down, you see how it's going through and changing the pieces of this. So let me start this debugging one more time and show you that it is running here. All right, and I'll open the app as we're getting right up against time here. I'll let this start, and you'll see how the title appears now and how it gives me that fix inside my code. And we'll take a brief look at writing unit tests, and we'll wrap things up. So unit tests are really where you want to be building this. You don't want to be going through and doing this Visual Studio run each time. This is a very visual way for us to learn about it. So there's my while statement. Now it should come up, and I should get the error, because that's, I believe, how I left it saved. Yes, loading in the background. And I want to see over there, you can see it's still doing its thing. Come here, you. Right. And come on, I'm waiting for it to finish loading. It's not completely loaded here. I can tell. See the little circle that pops up? It's taking its good old time here. Why isn't it showing me these? Now I've done it. Now I've gone and broken it entirely. Because we had this working just a minute ago. Like, it was showing me everything. Because that's not mine. That's this other. Yeah. See? Look at that. Now I've broken it. Hang on. Put that other line back. No, that's in analyzer. What? Do that again. What did I change over here? That it doesn't like it now. One more time, and then I'll show you the unit test. I'm not sure what I changed there, what I broke. I think it's got two analyzers that are kind of fighting with each other. Can you use an analyzer for static code generation? A little bit. Yes. How do I get the green arrows at the left of the Visual Studio Editor? Which green arrows are you talking about? Yes, yes. It's still loading in the background. See, loading extensions. Taking its good old time. Come on. There we go. Come on. Finish spinning that circle, and thank you. Yeah, it's not showing me mine anymore here. I don't know why it's suddenly not doing that. What did I change? Other than the name. I changed the name. Is it just upset because I put the extra name up there? I mean, maybe. Right, so not the code fix. There's a similar resources for the code fix. Go back over here. Change the title. Enclosed statement in curly braces. Yeah. I'm not quite sure why it's not popping properly here. So, the inheritance peak could be, but it's not. There's nothing that's being inherited there. The best way to get the result of a task, do an await. I did delete that one line, but it was in the code fix. It wasn't in the analyzer. But the analyzer, yeah, broken demos as I'm going through and doing things live, right? Feels bad, man. So, and you can see why this is painful to try and do. Yeah, we're good on. I'm just about out of time here, so I'm going to need to wrap quickly. While I'm waiting for that, there is a unit test project that's made available to you here, and there are blocks of code that you can write so that you can say, well, here's a test block of code, literally as a string inside your unit test. And I've got it set up with a very simple structure there so I can test if the brace is added, and there's how it should output. And for some reason it's not analyzing, picking up the analyzer and applying the test and giving me the result that I want here. And I need to dig through and figure out why that isn't. But it's very easy to say this is the before code, this is the after code. And there's ways to provide highlights inside there to indicate, well, this is where I expect the analyzer to identify an issue. Like it should, right? I can apply this type of syntax, vertical pipe, square brace, and you can tell it, I expect this code to be highlighted by the diagnostic. And I'm not getting the test to return that information properly for me. There it is. It was the name that I gave it. I put spaces in it. There we go. Brace analyzer, the brace expected. And if I click into this, Fritz says add braces. And if I click that, now it does the replace because this is being reported for that one up top. This one is the same way. Fritz says add braces, and it wraps it in braces. There we go. That's what we wanted to see. So I am just out of time. That's how you can walk through and verify the analyzer is running. Unit tests so that you can write the before and after code, and you can detect, you can raise issues, raise an error when and check that the syntax is highlighting appropriately by the analyzer. Really, really cool stuff. Let me head back over to the main screen here, and let me wrap this up. Oh my goodness. Not that screen. This screen. Hello. So I'm going to go back through the source code. The source code is over there inside the GitHub repository. But this is not for source generators. This is for analyzing your code and providing code fixes. Source generators is another topic that's even more in depth, even more advanced, because now you're writing code to generate more code, not just fix code. So let me wrap this up, and we'll call it a day. All the documentation for this, the samples, links to the source code, It's all available just below here. Check it out, github.com/CSharpFritz/C# with CSharpFritz. Thank you so much for watching. I appreciate you joining me. Next week, we're going to be talking about Open API with our friend Shane Boyer. Yeah, he's a friend named Shane, so he's a friend. Join us next week. We're going to be talking about that. I'll have some updates for you inside the GitHub repository. I think I need to turn this into a DevTO post, talking through building and testing your first analyzer and showing some of this. And I'm going to change that demo from braces to something else that's a little bit more interesting that isn't available out there. All right. Those of you that are watching on YouTube, I hope you have a great day. Check out all kinds of videos that are here on the .NET YouTube channel. There's also going to be some videos a little bit later today for everybody if you're on YouTube, if you're on Twitch. That'll be hosted right here. I believe the Docs team is going to be coming up. And if you're on Twitch, let's get ready for a raid. Let's take a look at who else is streaming on the big Twitch TV network that we can connect you with. And, yeah, set up a raid, go visit those other folks and have a, well, hopefully learn some more really cool tech that's going on here on Twitch. Taking a quick peek. Gosh, wow. Not too many people streaming right now. I want to see if there's somebody different we can go to. Let me see, who else can we visit? No. That would be weird. I'm not going to do that. I could go there, but that would be weird. That would be weird. I'm up for weird. We could do weird. Let's do something different. I'm gonna go to another science channel, but I'm gonna go to the chickens. Where'd they go? I just had them up here in front of me. Yeah, let's go to Our Chicken Life. Codephobia is on, yes. But I know he's not entirely thrilled with getting big raids coming in. It sometimes is not his cup of tea. So we're going to go over and check out Our Chicken Life. That's a series of cameras around a chicken coop that you can control over here on Twitch. Thank you so much for watching. We'll see you a little bit later today for the Visual Studio Docs show, for the .NET Docs team and their show. Tomorrow, Community Stand-Up, and I'll be over on my stream talking about Blazor tomorrow. Have a good one.